This is Spacetime, Series 21, Episode 97. Coming up on Spacetime, the most luminous galaxy ever seen eating its neighbours. Planet Earth about to get its best view in ages of the Comet 46P Wirtanen. And December Skywatch looks at the Geminids and Ursids meteor showers. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
The most luminous galaxy ever discovered is cannibalizing not one, not two, but at least three of its smaller neighbours. The findings, reported in the journal Science and in the Astrophysical Journal, show that the galaxy's unusual brightness is being caused by a material being gravitationally ripped off other galaxies. The cannibalistic galaxy, identified as WISE J224607.55 minus 052634.9, was discovered in 2015 by NASA's Space-Based Wide-Field Infrared Survey Explorer telescope, WISE. The galaxy is by no means the largest or most massive galaxy ever detected, but it radiates at some 350 trillion times the luminosity of the Sun. The new observations using the European Southern Observatory's ALMA, the Atacama Large Millimetre Submillimetre Array Telescope in Chile, have revealed distinct trails of dust being pulled into this monster galaxy from three smaller satellite galaxies. These trails contain about as much material as the smaller galaxies themselves, and it's unclear whether those galaxies will escape their current fate or whether they'll end up being completely consumed by their luminous neighbour. Most of this galaxy's record-breaking luminosity comes not only from the stars in the galaxy, but also a collection of hot gas and dust concentrated around the galactic centre. And at the heart of this cloud is a truly monstrous supermassive black hole, at least 4 billion times more massive than the Sun. This massive black hole's intense gravitational pull draws in matter at high speed, crashing together and heating up to billions of degrees, causing the material to shine with incredible brilliance. Galaxies that contain these type of luminous black hole-fueled structures are known as quasars. And just like any engine on Earth, this galaxy's enormous energy output requires an equally high fuel input. In this case, it means the gas and dust needed to form stars and planets to replenish the cloud around the central black hole. This new study shows that the amount of material being accreted by the galaxy from its neighbours is enough to replenish what's being consumed, thereby sustaining the galaxy's tremendous luminosity. The study's lead author, Tanio Diaz Santos from the University of Diego Portales in Santiago, Chile, says the feeding frenzy's already been ongoing for some time and is expected to continue for at least a few 100 million years more. This kind of galactic cannibalism is not uncommon. Astronomers have previously observed lots of galaxies merging with or accreting matter from their neighbouring galaxies. In fact, our very own galaxy, the Milky Way, is currently accreting material from two nearby satellite galaxies, the Large and Small Magellanic Clouds, and it's also consuming material from another galaxy on the other side of the Milky Way called the Sagittarius Dwarf. But this newly detected galactic cannibal is by far the most distant galaxy ever found to be accreting material from multiple sources. In fact, the light from its cosmic feast has taken some 12.4 billion years to reach us. So astronomers are seeing this object at a time when our universe was just 1/10 of its current 13.8 billion year age. That makes this galaxy fit into a special category of especially luminous quasars known as hot dust-obscured galaxies, or hot dogs. Astronomers think lots of quasars probably get some of their fuel from external sources. One possibility is that these objects may receive a slow trickle of material from the space between galaxies. Another is that they feed in bursts by eating up other galaxies, which appears to be what's happening with this hungry monster. Now, it's still unclear whether this beast is representative of other obscured quasars, those with their central black holes obscured by thick clouds of dust, or if this is a special case. One of the study's co-authors, WISE project scientist Peter Eisenhardt from NASA's Jet Propulsion Laboratory in Pasadena, California, says this galaxy may well be one of a kind. That's because it's nearly twice as luminous as any other galaxy found with WISE, and because it formed so very early in the universe's history. However, Eisenhart and colleagues have found other, admittedly smaller but generally similar galaxies with wires, distant, dusty, and thousands of times more luminous than typical galaxies today. So it could be that astronomers are seeing what's going on during a key stage in the evolution of galaxies and obscured quasars. Ultimately, this galaxy's gluttony may lead to its self-destruction. Scientists hypothesize that obscured quasars that gather too much material around them could end up spewing gas and dust back out through the galaxy. And this onslaught of material could halt the formation of new stars, essentially pushing the galaxy into early retirement while other galaxies continue to renew themselves with the birth of new stars. I'm Stuart Gary. You're listening to Spacetime. This month will provide skywatchers with their best view of the comet 46P Wirtanen. The small, short-period Jupiter family comet has an aphelion, that is, most distant point in its orbit around the Sun, of between 5 and 6 astronomical units, hence the name Jupiter family comet. An astronomical unit is about 150 million kilometres or 8.3 light minutes, the average distance between the Earth and the Sun. Wirtanen has an orbital period of 5.44 years and is estimated to be about 1.2 kilometres wide. On December the 16th this year, the comet will pass just 11,680,000 kilometres, or 0.0781 astronomical units from Earth, reaching an estimated magnitude somewhere between 7.5 and maybe even as high as 3, making it the brightest close approach for the next 20 years. Needless to say, astronomers worldwide are organising an observing campaign to capitalise on the favourable circumstances of this apparition. Interestingly, this comet was the original target for the European Space Agency's Rosetta mission. However, that target was later changed to Comet 67P Cherenkov-Gerasimenko when mission managers failed to meet the launch window for Wirtanen. Still, the 2018 close approach combined with Wirtanen's brightness provides a great opportunity to study a potential future spacecraft mission to this target. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
A comet called Wirtanen, and the reason we're talking about that is because it's almost upon us, not literally, but it will be visible in the night's sky, we hope.
Yes, that's right. It will indeed be visible in the night sky. It's the person who discovered it, despite having a Norwegian or Scandinavian sounding name, was actually American, so it's probably Wirtanen.
Okay.
With a W, who was at the Lick Observatory when he discovered this comet back in 1948. It's what we call a short period comet. From time to time, it passes close to Jupiter, which kind of disturbs the orbit. So its orbital period changes slightly. It's very interesting the way these things evolve because of the gravity of the giant planet Jupiter. But this year, we've got a really good chance of seeing it in the night sky as it progresses southwards. It's closest to the Earth on, I think, December the 15th and 16th, when it will attain what we call third magnitude, which means well within the naked eye visibility. The only problem is it will be rather a full moon at that time, and the comet itself has got a very diffuse coma as basically the nebulous region around the comet caused by the ices on the comet outgassing and turning into a plasma. So it's diffuse. It means it's not, a well-defined, sharply defined object. It is going to be, I think, quite difficult, but with binoculars, it should be easy to see this sort of fuzzy patch. There will be plenty of places on the web to check exactly where it will appear in their skies. But it's looking good. There's some very nice images already of Wirtanen taken by people with normal small-sized telescopes.
And it's green, which is...
Yeah, the green is, I think that comes from carbon monoxide emission, if I remember rightly.
So it's a pretty dirty comet.
All comets are dirty.
Yeah.
That's what they are, balls of dirt held together by ice.
Okay, so that's one to keep an eye out for, and it'll be closest to Earth since 1950, and that'll happen on December 15 and 16. And I'm guessing because of our orbital properties and its movement, most people will be able to see it.
Yes, I think that's right. It's in the northern sky when it's at its closest, but it's sufficiently far south that we should see it in the south too.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And time now to turn our eyes to the skies with December Skywatch. December is the 12th and final month of the year in both the Julian and Gregorian calendars. It got its name from the Latin word decim, meaning 10, because it was originally the 10th month of the year in the old Roman calendar, which began in March. Let's start our tour of the night sky in the west, where midway up from the horizon is Fomalhaut, the brightest star in the constellation Pisces Astronus, the southern fish. Fomalhaut is a young, white, spectral type A main sequence star, about 1.8 times the diameter of the Sun, located about 25 light-years away. Main sequence stars are those undergoing the fusion of hydrogen into helium in their core. In 2008, astronomers detected planets orbiting Fomalhaut. It's not known if anyone was looking back. 5,000 years ago, the ancient Mesopotamians used Fomalhaut to mark the northern winter solstice. Now, looking just to the left of Fomalhaut is Achernar, or Alpha Eridani, the brightest star in the constellation of Eridanus, the river. Located 139 light-years away, Achernar is about 7 times the diameter of the Sun and rotates about 15 times faster, giving it an oblate spheroid shape. The effect of that rapid rotation is that the star flattens at the top and bottom and bulges out in the middle. In fact, its equatorial diameter is about 50% greater than its polar diameter. Achernar is actually part of a multiple star system, Alpha Eridani A and Alpha Eridani B. The primary star, Alpha Eridani A, is a hot blue spectral type B main sequence star. Its smaller companion, Alpha Eridani B, is a spectral type A white star. The pair orbit each other at a distance of about 12 astronomical units. Now, moving further to the left from Achernar and just above the horizon, you'll see the star Canopus, brightest star in the southern constellation of Carina the Keel, and the second brightest star in the night sky after Sirius. Canopus is a white giant star nearing the end of its life, located about 310 light-years away. It has about 8.5 times the mass of the Sun, and is now expanded out to about 71 times the Sun's diameter. Canopus is some 1,300 times as bright as the Sun, and is in fact the brightest star within 700 light-years of Earth. Its name originates in Greek mythology from the time of the Trojan Wars, and the navigator for Menelaus, the king of Sparta. Located between Canopus and the Southern Cross, also in Carina, in the Trumpler 16 open cluster, is the ticking time bomb that is the binary system of Eta Carina, a pair of huge blue stars undergoing the final phase of their existence before exploding as a massive core collapse supernova. Located some 7,500 light-years away, the pair is some 5 million times more luminous than the Sun, and are enshrouded in a thick cocoon-like cloud of gas and dust, called the Homunculus Nebula. The nebula was created when Eta Carina underwent a spectacular eruption starting in 1837. Known as the Great Eruption, it eventually reached its peak in 1843 when it was one of the brightest objects in the night sky, before gradually fading away again by 1856. Eta Carina then underwent a slightly smaller eruption in 1892 and has been steadily brightening again since about 1940. The two main stars in the Eta Carina system have an eccentric orbit with a period of 5.54 Earth-years. The primary is a peculiar star, similar to a luminous blue variable star, which may have originally had somewhere between 150 and 250 times the mass of the Sun, of which around 30 solar masses has now been lost. Interestingly, this is the only star known to produce ultraviolet laser emissions. The secondary star in the system is also hot and highly luminous. It's a spectral type O main sequence blue star, and probably around 30 to 80 times as massive as the Sun. While Eta Carina is destined to go supernova, no one can be sure exactly when that's going to happen. As a single star, a star originally around say 150 times as massive as the Sun, would typically reach core collapse as a Wolf-Rayet star within about 3 million years. At low metallicity, many massive stars would collapse directly into a black hole with no visible explosion, or what's known as a subluminous supernova, while a small fraction would produce a pair instability supernova. But at say solar metallicity or above, there should be sufficient mass loss before the collapse to allow a visible supernova to be observed. Now, if there is still a large amount of expelled material close to the star, the shock formed by the supernova explosion impacting the circumstellar material would officially convert the kinetic energy into radiation, resulting in what's called a superluminous supernova or a hypernova, several times more luminous than a typical core collapse supernova and lasting much longer. highly massive progenitors could also eject sufficient nickel into space to cause a superluminous supernova simply through radioactive decay. The resulting remnant would most likely be a black hole, since it's unlikely such a massive star could ever lose sufficient mass for its core not to exceed the limit for a neutron star. But the existence of a massive companion star in this system brings many other possibilities into play. One theory of Eta Carina's ultimate fate is collapsing to form a stellar mass black hole, with the energy released as jets along its axis of rotation as gamma-ray bursts. A typical core collapse supernova at the distance of Eta Carina would look as bright as Venus, the third brightest object in the sky after the Sun and Moon. But a superluminous supernova could be 5 magnitudes brighter, and potentially the brightest supernova in recorded history. The good news is Eta Carina is not expected to produce a gamma-ray burst, and its rotational axis is not currently aimed near Earth. Okay, let's turn to the east now, and looking just above the horizon is the star that outshines Canopus to take the title of the brightest star in our night sky, Sirius, the dog star. Sirius is twice as bright as Canopus. It's actually 2 stars. There's a young spectral type A main sequence white star, Sirius A, which is about twice as big and 25 times as bright as the Sun. And then there's Sirius B, a small white dwarf, the remnant white-hot core of a dead star. The system is between 200 and 300 million years old and was originally composed of 2 bright white stars. The more massive of these, Sirius B, consumed its resources, becoming a red giant before shedding its outer layers and then collapsing into its current state as a white dwarf around 120 million years ago. At a distance of just 8.6 light years, Sirius is the 5th closest star to the Sun. Mind you, Sirius is getting closer every day. It's gradually moving towards our solar system, and so it will continue to increase in brightness over the next 60,000 years. Sirius is known colloquially as the dog star, reflecting its prominence in the constellation Canis Major, the Greater Dog. The heliacal rising of Sirius marked the flooding of the river Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. Heliacal rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. By carefully monitoring and watching Sirius's movement across the sky, the ancient Egyptians determined that it would be visible every night for 295 1/4 nights, followed by 70 nights of absence. And that was important because it allowed the ancient Egyptians to determine that the year was 365 1/4 days long. And the fact that they were able to do this thousands of years ago is truly quite an amazing achievement. Not far from Sirius in the northeastern skies just above the horizon is the spectacular constellation of Orion the Hunter. And in there you'll see a very bright red star, a red supergiant called Betelgeuse, better known to most people these days as Betelgeuse. Just don't say it 3 times. In ancient times, before centuries of mispronunciation, the star started out with the name Ipdal-Jausa. Betelgeuse is one of the largest and most luminous stars visible with the unaided eye. Located just 430 light-years away, this bloated old star nearing the end of its life is truly massive, some 1,100 times the diameter and 100,000 times the brightness of the Sun. Like Eta Carina, Betelgeuse is destined to explode as a core collapse supernova sometime in the near future. Betelgeuse marks the right shoulder of Orion the Hunter, although it's all upside down from the perspective of anyone in the southern hemisphere, as Orion was a hunter in Greek mythology, and so the constellation was viewed from the northern hemisphere. The earliest depiction that's been linked to the constellation of Orion was a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists estimate the carving was produced sometime between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including the ancient Babylonian star catalogues dating back to the Late Bronze Age. In Greek mythology, Orion was the gigantic, supernaturally strong hunter of ancient times. He was the progeny of a Gorgon and Poseidon, also known as Neptune, the god of the sea in the Greco-Roman tradition. The goddess Gaia came to be enraged with Orion after he boasted that he would kill every animal on Earth. So she sent a scorpion to sting Orion to death. However, Ophiuchus the surface bearer revived Orion with an antidote. This is given to be the reason why the constellation Scorpius chases Orion across the sky, with the constellation Ophiuchus standing midway between them. One of the other major stars in Orion is Rigel, Orion's left foot, a blue supergiant. Having exhausted its core hydrogen supply, Rigel is now swollen out to between 79 and 115 times the Sun's radius. It's fusing heavy elements in its core, meaning it too will likely go supernova and collapse to form a neutron star. Rigel is estimated to be somewhere between 120,000 and 279,000 times as luminous as the Sun. It's actually a binary system located 860 light-years away. Its companion star Rigel B is some 500 times fainter than the supergiant Rigel A and can only be seen with a telescope. Mind you, it's worth a look because Rigel B is actually a spectroscopic binary system comprising two main sequence blue-white stars. Spectroscopic binaries are double star systems orbiting each other in such a way that they can only be visually separated from our vantage point here on Earth by their spectroscopic signatures. The two stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun respectively. Interestingly, one of these stars, Rigel BB, may itself be a binary. Rigel B also appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star, about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It's a young star with an estimated age of just 25 million years. Mind you, that's old enough for a star of this mass to have consumed the hydrogen in its core and begin to evolve away from the main sequence into a blue giant. If you look at the 3 stars which make up Orion's belt, you see another 3 stars which make up Orion's sword hanging from the belt. And again, that's hanging upwards rather than downwards for listeners in the southern hemisphere. If you look carefully at the middle star, you'll notice it's a bit fuzzy looking. That's because it's not a star, but rather the Great Orion Nebula, Messier 42. Located just 1,344 light-years away, M42 is the nearest massive star-forming region to Earth. The nebula is estimated to be some 24 light-years across, with a mass of more than 2,000 suns. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky, and is among the most intensely studied celestial features. The nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have been able to directly observe protoplanetary disks, brown dwarfs, intense and turbulent motions of gases, and the photoionizing effects of massive nearby stars in the nebula. The Orion Nebula also contains a very young open cluster called the trapezium, due to the asterism of its 4 primary stars. The trapezium is a component of the much larger Orion Nebula cluster, an association of some 2,800 stars, all within a diameter of just 20 light-years. One of the most stunning nebula in the constellation Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just to the south of the star Alnitak, which is the farthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1,500 light-years away, the Horsehead Nebula was first detected in 1888. It's one of the most identifiable nebulae because of the shape of its swirling clouds of dark dust and gases, which really do bear an uncanny resemblance to a horse's head when viewed from Earth. One of the astronomical highlights of December is the annual Geminids meteor shower, which usually peaks around December the 13th and 14th. Radiating out in the direction of the constellation Gemini, the Geminids are unusual in that they're not generated by a comet as most other meteor showers are, but are produced by the debris trail left behind by the asteroid 3200 Phaeton. This makes the Geminids, together with the Quadrantids, the only major meteor showers not originating from a comet. Now, as we mentioned last week, 3200 Phaeton is highly unusual. Its high orbital eccentricity more closely resembles that of a comet rather than an asteroid, and in fact it may actually be an asteroid that simply ran out of the volatile gases that characterize a comet. Phaeton's orbit crosses all the inner terrestrial planets, Mercury, Venus, Earth and Mars. The 5-kilometre wide asteroid is classified as potentially hazardous. And that would be almost funny if it wasn't so serious. You see, Phaeton is named after the son of the Greek sun god Helios. According to legend, Phaeton almost destroyed the Earth by stealing Helios's chariot and then scorching Earth with the sun, almost causing the apocalypse. Interestingly, Phaeton does approach the Sun closer than any other named asteroid, with a perihelion of less than 21 million kilometres, less than half Mercury's perihelion distance. Coming so close to the Sun causes Phaeton's surface temperature to reach more than 750 degrees Celsius, and observations by NASA's STEREO spacecraft have observed dust trails radiating off the asteroid's surface. In fact, in 2010, Phaeton was imaged directly ejecting dust. Scientists think the intense heat generated by its close approaches to the Sun causes fractures in the gravel and rocks on the asteroid's surface, similar to mud cracks in a dry lake bed here on Earth. Phaeton's composition also fits the notion of a cometary origin. See, it's classified as a B-type asteroid because it's composed of dark material. B-type asteroids are thought to be primitive, volatile, rich remnants of the early solar system. Its composition, orbit and dust trail have all led astronomers to refer to Phaeton as a rock comet. That might be why Geminids meteors have a yellowish hue to them and tend to be a bit larger and more solid than typical meteors from comets. They also move more slowly, travelling at around 35 kilometres per second, compared to some cometary meteor showers which travel at speeds of up to 72 kilometres per second. Interestingly, the Geminids are thought to be intensifying every year, with recent showers seeing up to 160 meteors an hour under optimal conditions. In the Northern Hemisphere, expect to see up to 120 meteors an hour between midnight and 4 a.m. For Southern Hemisphere listeners, the news isn't quite so good. You won't see many Geminids, perhaps 10 to 20 an hour. That's because the radiant won't rise above the horizon. For listeners in the Northern Hemisphere, there is a second meteor shower in December, the Ursids radiating out from Ursa Minor, the Little Dipper. The Ursids are generated by debris left behind by the comet 8P Tuttle. They're a compact stream peaking on the night of December the 22nd and the early morning hours of December the 23rd. Just look towards the bowl of the Little Dipper, and you should see about 10 meteors an hour. Of course, December also marks the December solstice. It'll occur at 9:23 in the morning Australian Eastern Daylight Time on Saturday, December the 22nd, when the Sun reaches zenith, appearing to be directly over the Tropic of Capricorn. For North American listeners, that'll be 17:23 on Friday afternoon, December the 21st, US Eastern Standard Time, and 10:23 in the evening of December the 21st, Greenwich Mean Time. Of course, in the United States and most of the Northern Hemisphere, the December solstice marks the first day of winter. But the good news is that from now on the days start to get longer again. But south of the equator, summer has well and truly arrived, but that means the days will start getting shorter. On the day of the December solstice, Earth's south pole is tilted towards the Sun. The Sun rises south of east and sets south of west, reaching its most southerly declination of 23.4 degrees. Of course, the seasons are governed by the tilt of Earth's axis as it journeys around the Sun. When the south pole of the Earth is tilted towards the Sun, it's the Southern Hemisphere summer. 6 months later, and the south pole's tilted away from the Sun, it's the Southern Hemisphere's winter. In between these, we have the autumn and spring equinox. Now, all this shouldn't be confused with Earth's closest orbital position to the Sun, perihelion. It usually occurs about 2 weeks after the December solstice, while its furthest orbital position from the Sun, aphelion, is about 2 weeks after the June solstice. That means the next perihelion will occur on Wednesday, January the 3rd, 2019, at 16:19 in the afternoon, Australian Eastern Daylight Time. That'll be 12:19 a.m. US Eastern Standard Time, and 5:19 in the morning, Greenwich Mean Time, when planet Earth will be just 147,099,760 kilometres from the Sun. Of course, the thing is, temperatures on Earth aren't determined by Earth's orbital distance from the Sun, but rather the angle of the Sun's rays striking the Earth. In summer, the Sun is high in the sky, and the rays hit Earth at a steep angle. In winter, the Sun is lower in the sky, and the rays strike Earth at a more shallow angle. Now, to look at the rest of the December night skies, we're joined by Jonathan Nally, editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, let's start with what we can see in the middle of the evening, which is time most people are out looking at the sky, of course. The Milky Way, which is just our galaxy seen from the inside, you'll see that stretching all the way across the sky from the south, around the sort of eastern part of the sky and up to the north. So that's the Milky Way. That's our galaxy seen from inside. Way down south, inside the Milky Way, you'll see the Southern Cross. And the Southern Cross is upside down during December. Now, it all depends on your latitude whether you can actually see it. People in the Northern Hemisphere can't see it this time of year. Most of them can't see it any time of year, but if you're way down towards the equator in the Northern Hemisphere, you can see the Southern Cross at some times. But at the moment, because it's way down south and upside down, even in Australia, say, or New Zealand, if you're at the latitude of Sydney, you're probably going to miss the Southern Cross during the evening because it'll be behind trees and houses and things.
Yeah, it's all right. I'll look at Orion this time of year instead.
Orion instead. 5 or 6 hours later, the cross will be up a little bit higher. If you're further north than Sydney, then you're probably not going to see the cross at all time of year. If you have dark skies, you should be able to make out the two nearest sizable galaxies to our own, the Large and Small Magellanic Clouds. They're straight down south, and they're nice and high. And they just look like faint, fuzzy clouds. In fact, you could probably mistake them even for clouds if you didn't know that they were galaxies. But they are, in fact, millions and millions of stars. Around to the east of the large cloud is a bright star that's called Canopus. This is actually the second brightest star in the night sky. And further around still to the east, you'll find the star Sirius, which is the brightest star in the night sky. It's also known as the Dog Star because it's in the constellation Canis Major, or the Greater Dog. Now, in the eastern sky, you just mentioned it, about halfway up from the horizon is Orion the Hunter.
Through a decent telescope, you get to see things like the Horsehead Nebula in the constellation of Orion, the Orion Nebula itself, a huge star-forming region, the nearest star-forming region to our solar system, and it's just a spectacular sight.
It is a really spectacular constellation. It's just a line of sight effect that we're looking in from our direction of Earth, the solar system, at that particular group of stars, that we get this nice combination, this nice arrangement of stars in the night sky. It's one of my favourite constellations too. And the thing is, for us in the Southern Hemisphere, seeing Orion in the evening sky like that, that shows that summer's here.
Yes, yeah, very much so.
For our friends up north, that means winter's coming and it's getting cold. And there's pluses and minuses to that because, winter time, depending on where you are, okay, you might get lots of rainy, cloudy weather, but some places that don't get lots of rainy, cloudy weather during winter, you can get nice, crisp, clear skies, which are really good for stargazing.
Well, they had some snow during Thanksgiving in the US, so it's been really cold in the States.
Yeah, well, if you can get sort of cold, still conditions, even though it's cold to be outside stargazing, it can give you really good viewing conditions just with the naked eye or through a telescope. For us down here in the south during this time of year when it's summer, it's great because it's warm and it's generally not raining, but the problem is that the days are much longer, so the hours of daylight are longer, I should say, and the hours of nighttime are shorter, so you get less time.
And also the warmer weather means more dust is likely to rise as well.
Yeah, dust, and you got disturbed atmosphere, you get air currents and things which make the stars twinkle, which astronomers don't really like. It looks pretty, but when you try and look through a telescope, all that just blurs the what you're trying to look at. Anyway, where were we? Orion. So around to the north of Orion, in the northern part of the sky, you'll see a reddish star that makes up one corner of a fairly large triangle or wedge of stars. Now, this star is called Aldebaran, and the triangle is a star cluster called the Hyades. Now, you don't need a telescope to see it. You can see it with the unaided eye, but it's even better if you have a pair of binoculars. If you've got a pair of binoculars, take a look, because it's a really pretty sight. And just sort of a little bit further around again from the Hyades is another star cluster called the Pleiades.
The Seven Sisters.
Seven Sisters, yeah. And lots of different cultures all around the world for thousands of years have known this star cluster, or have called this star cluster the Seven Sisters. And as far as people can tell, these cultures were never in contact with each other.
Yeah, it's like flood stories. Every culture seems to have a great flood story.
Yeah.
Ours is Noah. Every culture seems to have one. And you got to wonder whether it's something that goes back to out of Africa times, 70,000 years ago.
Or with the Seven Sisters or the Pleiades, it's a really compact cluster of bright, sparkly stars, and it looks really pretty. So, it's
an open cluster, isn't it?
It's an open cluster of stars, yeah. There's two types of star clusters. Open cluster where the stars are just sort of higgledy-piggledy, but they're grouped together. And then you've got what's called globular star clusters, which look like a ball of stars. They have millions of stars in them generally, and because they've got so much gravity combined with all these millions of stars, it forms itself into a ball shape. But open clusters, they're smaller, and the stars are scattered around randomly, but they're more or less in the same area. So anyway, the Pleiades looks really tremendous, particularly from dark skies. You can probably make out 6 or 7 stars, depending on how good your eyes are and how dark your sky is. And if you've got a pair of binoculars, or you can borrow a pair, have a go, because it looks really, really, really pretty. Okay. Now, as far as the planets go at the moment, there are 2 to see in the evening sky. sky, there's Saturn and Mars. Saturn is low down towards the western horizon. We're sort of within the glow of the evening twilight after the sun's gone down. Saturn's getting lower each day during December, so by about mid-month, in fact, it's going to be too low to be seen. It'll be way down in the glare of the sun, and that's because it's going around the other side of the sun from us, and it, therefore, obviously, is going to be lost in the glare, and we won't be able to see it. Mars, which is up higher, is easier to see in the northwest. It just looks like a fairly bright, orangey red sort of star, and it'll be nice and prominent all month long, okay? So you'll be able to, any night you can go out and have a look at it. And when you do have a look at it, of course, spare a thought for NASA's InSight spacecraft, which just landed there recently.
Yes, I was actually doing a radio piece on that just the other day, and the person I was speaking to called it the planet of the droids, which is actually quite true when you think about it, and it's populated by droids.
Well, it's got these rovers still there. It's got stacks of spacecraft circling it, orbiting it. Yeah, so there are quite a lot there. You almost need air traffic control for the place. Okay.
Still no word from Opportunity, sadly, however, but hopefully that'll change.
Yeah,
it's the windy season where Oppie is right now.
You never know. It might come back to life. Fingers crossed for that. The other planets that are bright enough to be seen with the naked eye are all morning objects at the moment, so you need to get up before dawn. The brightest and highest in the sky is Venus, and you can't miss it because it's the brightest thing in the sky other than the moon during the night time. So take a look any morning during December, look out to the east, and you'll see a big bright light in the sky, and that's Venus. Now down below it will be Jupiter, also bright, and further down still will be Mercury, again sort of bright but much smaller. All right, so get out and have a look for those three because they were all in the sky at the same time. If you're out and about on the morning of the 22nd of December, have a look because Jupiter and Mercury are going to be right next to each other in the pre-dawn twilight. So that should look pretty good, presuming you've got good skies. Jupiter will be the brighter of the two and Mercury is the fainter of the two.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is Spacetime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. There have been global cries of outrage to claims Chinese scientists have produced the world's first genetically edited designer babies. Hejiang Koi from the Southern University of Science and Technology of China says he carried out the so-called gene surgery on the embryos of twin girls to disable a genetic pathway which can be used by HIV to infect cells. Scientists around the world have responded with concern to the news due to the technical and ethical issues surrounding the work. The main concerns surround questions regarding what changes, other than those intended, may have been generated by this unneeded surgery. Scientists warn it's almost impossible to say for sure whether altering a gene involved in HIV infection could also have other unexpected physiological or medical consequences. Also of concern is the fact that the genetic change will be passed on to all future generations of that family. Not only any potential benefits, but also any potential problems. Finally, the work bypasses international safeguards, and its true success will never be known, as it was not submitted for the normal scientific peer review process. A new study by the World Meteorological Organization says there's a 75 to 80% chance of an El Nino developing by February 2019, although it's not expected to be a strong event. The latest updates based on sea surface temperatures across the east and central tropical Pacific, which have been at weak El Nino levels since October. However, the atmosphere has not yet responded to reflect a typical El Nino pattern. Model forecasts suggest this will change within the coming month or two, with a 75 to 80% chance of a fully fledged El Nino occurring. The data indicates Australia is likely to have above normal surface air temperatures over summer. It means hot, dry conditions for eastern Australia, possibly a continuation of the drought, and stronger hurricane conditions for the Americas. Now, speaking of weather, 2018 now looks set to become the fourth hottest year ever recorded, and that continues a trend which has seen the 20 hottest years on record experienced over the past 22 years, with the past 4 years being the 4 hottest years on record. The World Meteorological Organization says the new data shows that the planet is set to miss the climate change targets agreed to as part of the Paris Agreements. Other telltale signs of climate change, including sea level rise, ocean heat and acidification, and sea ice and glacier melt, all continue, while extreme weather has left a trail of devastation across all continents. The report also found that global temperatures for the first 10 months of 2018 were nearly a degree Celsius above the pre-industrial baseline. Continuing the bad news, and Australia's most endangered bird populations have declined by 50% over the past 30 years. The findings by Australia's new Threatened Bird Index were delivered at the Ecological Society of Australia's 2018 conference. The index combines data from 180,000 individual surveys from 35 separate monitoring programs on 43 threatened bird species. The study found that threatened migratory shorebirds have suffered the largest decrease, dropping by a whopping 70% on average over the past 30 years. You're listening to Spacetime. I'm Stuart Gary, and that's the show for now. You can subscribe and download Spacetime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.